I've been building these convolutional neural nets and fully connected nets in Excel for about a month now, and this was a wiring diagram for an Excel version of a convolutional net. And one of the advantages of doing it in Excel, and there are only a few, it becomes very transparent what the structures are. So if you've got three-dimensional arrays, you can actually see the blocks of data and see how they link up. And there's some reasonably complex Excel wiring in there, and as I did this, I found I made quite a lot of silly mistakes. So for instance, I was wiring different connected layers using a fixed array, and as I expanded it, I needed the fixed array because I was looking through the sheets. I ended up with gibberish. So here we have the formulae, which were for the derivative of the weight functions on the second layer of the convolutional network, looking at completely the wrong thing. It's utter rubbish. Yet the structure and the architecture of these nets is so robust that it was still getting 90% training accuracy just by relying on the final layers. So they're really robust. So I wanted to see, exactly how close I could get the accuracy to be, and this was a run of 700,000 iterations. It's a 10-digit batch run, so it's running 10 digits at a time. These are kind of very reduced resolution. The actual digits are, much more accurate. They're the Jan LeCun 28 by 28 digits. That's a 1, obviously, on each of the different layers. So I had more resolution than you're seeing on this screen, and I got training precision, which is the orange line you're seeing, and that's a cumulative precision. But then the green dots are the average over 1,000 iterations. So it doesn't accommodate all the baggage of the cumulative number, and it's giving a more accurate rate of where we're at. And you can see that the learned accuracy gets above 99%. But every 100,000 I ran a test on the test data set, which is a completely different set of data from the training data set. And you can see that it's declining. So these little patches, which were the training, are just getting worse and worse. And in fact, the best test was after 100,000 runs, where I was getting 98.5, which is, well, it's actually 98.4, which is state of the art. And there's various papers out there, and I saw this one recently, which is showing that I'm right up an error rate of 1.6 for a non-dropout ReLU activation convolutional neural net, even though I've got a smaller network than the LeNet 5. It's got less channels, etc. But I was getting right up there. So with data augmentation and with data augmentation, that's stretching and scaling the data, and using dropout and drop connect, I should be able to get 0.21, but I've yet to do that. So I was interested to see how it worked on the digits, and I got a good idea of how quickly it overfits. And then I decided I'd stuff in the enhanced EMNIST, which is, I think it's again from Jan LeCun, but it's effectively letters. So it's a much bigger data set. It's 124,000 training and 20,000 test letters. And I trained it for quite a while, and one of the biggest boosts I found to get it to getting it to only 90% or 89% test accuracy was to just keep reinitializing it until I got a steady and good initialization. So this run is the 144th best, at least 2 standard deviations from the norm, 144th best initialization set of parameters. And I'd run it for 1,000, see if it beat the previous curve. And this was the best curve I had for learning at 1K, 2K, 5K, and 100K cumulative precision, which was giving me 90% on the test data. And it works really well. All I had to do to stretch this from digits to letters was fairly simple. It was just the final layer 4, where I needed to stretch it from 10, 1 to 0 to 9, to 26, A to Z. But this did leave me with a slightly oddly shaped set of final layers, where I've got 15 neurons in layer 3 and 26 in layer 4. So I'd assume I could get better than that if I fix that, and clearly I'm going to get far better than this if I do some data augmentation and some dropout and connected dropout. But you can see it's quite effective when it's learning. Some odd effects in the test data, and it seems to be slightly alphabetically sorted because you're seeing lots of E's and N's, but I can fix that with randomization. I can't see a reason why the sequence of the test set is going to affect the test result. However, again, in building these spreadsheets, you make a lot of wiring errors, and you see them happening, and they're often quite hard to spot because, as I've said, they're very robust, so you don't know it's broken. But what I found on the learning curve was, as I changed the sampling, and I had a slight bug, which meant I sampled from the learning data in blocks of 10, and only 6,000 discrete blocks of 10. This is the digits, because there's 60,000. And I got pretty high learned rates, but when I fixed the algorithm half through that, I got a very interesting pattern change in the learning, a decrease and then an increase. And I'm going to blog about this, I'll put it on the site. But for now, this is where I've gone in the last couple of weeks, which is to look at the letters, where the Bayes error is definitely going to be higher. The Bayes error being effectively the theoretical amount of information that's hidden within the data. So if you've got categories that a set of data could fall into two categories, it's not going to it's going to trip Bayes error. You can't distinguish between the two. Humans get close to this, and in general, humans are the main measure of Bayes error. I think Bayes error on the digits, I think, is about 0.21% error. So what's it going to be on the letters? I'll run the extra fixes, but the next stage, I think, is to move on to more interesting nets, particularly capsule nets, where there's a lot of value to be had, I would thought, in Excel, because it's so grubby and right inside the data to build the capsules. And I'm hoping to see what that happens on digits and letters. I finished the Andorrain course yesterday. Brilliant, 5 courses, and completed those. So there's a load of sequence models I want to program, and then, of course, do a Python training course, TensorFlow Keras, so that I can start doing these things in the proper software and not Excel. But as I've said before, doing in Excel was quite a good way to learn this, to see the structure, to see the exposed arrays of data, and to see errors that you then need to understand and figure out what on earth is going on.